Hi to all judges and panel. We are from Siswasat FKKK. We are going to measure the weight, height, and diameter of our Siswasat. So this is our outside and the inside view. We decided to do the layer by layer because it has a better weight distribution. And this is our bottom view. Now we're going to measure the weight. The mass of both Siswasat and parachute is 224 grams. Now we're going to measure the height, and the height is 92.9 millimeters, while the diameter is 65.1 millimeters. Now we're going to do the launch sequence again. By using the nylon thread, we attach it to the Siswasat and release it when we want to launch it. This is our custom launch pad. As you can see, the ground station is over there. The distance is around 200 meters. And now Siswasat is ready to deploy. Siswasat deploy in 5, 4, 3, 2, 1. Deploy. Siswasat is deployed.
Okay, now ground station will start receiving data from Siswasat. The first column here is our quantiниan. What quantiниan does is it shows our Siswasat position. Here is the battery voltage, temperature, pressure, altitude, humidity, latitude and longitude. All this data is versus sample number. The latitude and longitude is our GPS location, and Siswasat will only sending GPS location for every 10 seconds. And now we wait for 2 minutes before launch crew will switch Siswasat data from sending telemetry data to read mode. What read mode does is when triggered, Siswasat will stop sending telemetry data and start to transmit the data that was stored on the microcontroller for the first 16 seconds, which is the EEPROM. Okay, 2 minutes has passed, and now the launch crew will switch Siswasat to the read mode. Okay, this is our data from the EEPROM. The first sample here, the first number is 42, which is the altitude. The second, the third and the fourth is our XYZ data. And now we wait for launch crew to send the SD card to compare the data from telemetry viewer and the SD card for our data validation.
Okay, for the next step, we're going to unscrew our nut at the bottom of our Siswasat to take out our SD card. The SD card is pulled. Next, we're going to take out the camera SD card. The camera is as a black box. And now we put it inside our secure box. Now we're going to deliver it to the ground station by using the motorcycle. secure box is successfully delivered to the ground station, and we insert it in the card reader and plug it in the laptop.
And I will export the data from telemetry viewer as a CSV file. Here is data collected from our telemetry viewer. The total sample number that we collected for 2 minutes is around 317. And now I will insert the SD card. Here is the data from our SD card, and I will convert it into the CSV file. Yes. Sorry. And now we will compare both data side to side. From the left side is our telemetry viewer data, and the right side is the SD card data. Okay, first we compare the first sample number. The temperature that was captured on the telemetry viewer is 35.64, which is the same as the SD card, 35.64. The pressure also the same. Altitude, humidity, and the battery voltage. Next, we will compare the last data taken on the telemetry viewer. Sample number 329, and the data from the SD card for sample number 329. Okay, the temperature from telemetry viewer is 36.84, which is the same as the SD card, while the altitude, pressure, humidity is also the same. That means that the data validated from our telemetry viewer and SD card is correct. And now, to convince you guys, I will start generate sample number from the internet to compare it with you guys. Okay, max sample number is 329 and generate. Okay, 222. I will compare the sample number for 222 here. Here for the SD card. Okay, the temperature for the sample number 222 is 36.47, and the temperature for sample number 222 on the SD card is also 36.47, which is the same. And the other data is exactly the same. Okay, next I will check the data for our GPS location. Here I will copy paste this data and save it on the Google Map. Here is our demonstration location right now. Okay, next. Okay, now we are done with the data validation from telemetry viewer and the SD card. And now I will validate data from the EEPROM. Here is our EEPROM data. And this is our first sample. For the first sample, here the first number is altitude. The altitude from the EEPROM is 42, and it saves in integers. That means it don't have any decimal places. For the altitude on the telemetry viewer is 42.53, which is exactly almost the same. The three last number on the EEPROM is our accelerometer, which is AX, AY, and AZ. Here is the accelerometer from the telemetry viewer, 217. From the EEPROM is also 217, negative 51. Here also negative 51, and 1022. And here also 1022, and here also 1022. Okay, to conclude the data validation, it shows that the transmission between the Tuafat to the ground station is transmitted successfully, and we managed to prove that our data validation is exactly the same.
1, 2, 3